All right, guys, let's take a look at 13 through 24 today. And after I finish this video, you're going to have another practice on already, okay? If you did not do the practice from yesterday, the already assignment from yesterday, which was teacher assigned, I'm going to let you go back and do it today. But regardless, I need both of those already assignments done by midnight tonight so I can put those grades in tomorrow, okay? All right, let's take a look at number 13. It says 2 divers are in the water, so we know they're below sea level. Our numbers are going to be negative. One diver is 65 feet below sea level, and the other one is 35 feet below sea level. So although you don't see a negative on either one of these numbers, the word below is going to indicate that those numbers are negative. So to represent 65 feet below in terms of a number, we would use negative 65 feet. To represent 35 feet below in terms of a number, we would use negative 35. It says write a numerical expression that's going to represent the distance. And of course, to represent distance, we have to subtract and we have to remember to use absolute value because distance can never be what? But distance can never be negative, guys. So we want to make sure we use absolute value. So when I get ready to write the expression, I don't care what number you put first because you're putting it in absolute value. All you need to do is subtract these two numbers. Doesn't matter which one you put first. So I'm going to start off with negative 65, subtract the other negative. But when you subtract the negative, of course, that other negative goes inside of, or the negative goes inside of parentheses. Now you could have also you could have also put the other number first. So you could have written negative 35 minus the other number, which is negative. So when you subtract the negative, put it inside of parentheses, guys. Okay, now this is to the left. Minus a negative is the same as plus, which tells us it goes to the right. So as far as the solution is concerned, I'm going to follow SADS. Same direction, add, different direction, subtract. They go in different directions. So we're going to start off with 65 minus 35, which is 30, but it's more to the left. So we end up with the absolute value of negative 30. But the absolute value of any number is positive, guys. So these two divers are exactly 30 feet apart. Now, if you set up the second expression as I did over here, if that's what you would like to use, you still follow SAD, same direction, add, different direction, subtract. This goes to the left. Minus a negative goes to the right. They go in different directions, so it's still 65 minus 35, which is still 30, but now it's more to the right. So it's the absolute value of positive 30, which is still 30. They're 30 feet apart. So regardless of what expression you write, what order you put the numbers in, it's fine as long as you subtract and put them in absolute value if you're talking about distance, okay? Excuse me. Let's take a look at number 14. During December, the average daily temperature in a town is -1.7 degrees Celsius. Okay, now it gave us the number in terms of like whether it's positive or negative. The average daily temperature in the same town, and let's write this as 3.5. Everybody fix it on your paper. Is 3.5 degrees Celsius lower in January. What is the average daily temperature in January? So we know that normally it's -1.7, okay? But that was in December. In January, it's 3.5 degrees lower than this, okay? So how do I figure out what's 3.5 degrees lower than negative 1.7? Well, you can add negative 3.5 to it, or you can write negative 1.7 and subtract 3.5. This is where it started, and this shows that it's lower or that it's going to be a decrease in temperature, okay? Same thing here, shows where it starts, And this shows that there is a drop or a decrease in temperature. Well, they both go to the left, so I'm going to add them. And we know when we add and subtract decimals that we line the decimals up. And they are both to the left, or they're both, you started off with a negative temperature and it dropped even farther. So what you would do is just keep it negative. It's even more negative. Or you can say that on the left, so it's negative. Negative 5.2 degrees Celsius, or negative 5 2/10 degrees Celsius is the temperature in January. And of course, that is 3.5 degrees colder than 1.7, okay? Negative 1.7. Can I take a look at 15? A submarine was situated 350 feet below sea level. Please do not write 350 as a positive. I hope the submarine is not floating in the air. Okay? So although I don't see a negative on that number, I know it's negative because of the word below. Okay, and what happens? Then it descends 200 feet. Well, to descend means to go down, guys. Okay? So we want to write a numerical expression to represent its new position. So what I'm going to do is I'm going to put where it started at negative 350. Negative 350 feet, and then it descended 200. So if it descended 200, I can add negative 200. Okay, this shows me where I start, and this shows me that I descended, guys. Now, you could have also written negative 350, which is where it started, and to descend means to subtract or go down. You could have also written that. But plus negative is the same as minus. Plus negative 200 is the same as minus 200. Either way, they both go to the left, so I would add. That would give me negative 550 feet. Or I could say that it's 550 feet, and I would have to use the word below sea level. That's the new position. I normally just put plus signs in between my numbers, and then if it seems like a positive number, I put positive. If it's more geared toward a negative number because of descends, I put negative. Now, some of you are going to be used to just writing it like this. That's fine with me. Do not do this, though. I've seen several students do this in the past. This is the same as a plus. That's not a descension. That's an ascension. It's going up if you do that. So you cannot write this because I need it to go what? I need it to go down, guys. Okay, let's look at 16. When Daria gets to school, the temperature is 5.7 degrees Fahrenheit. My God, it's freezing. The temperature changes by negative 9.5 degrees Fahrenheit by the time she goes to bed. So what's the temperature when Daria goes to bed? Well, it changed by that, guys, which means that the temperature dropped by that much. Well, where did it start? It started out here. So we're going to write 5 7/10 degrees plus the negative 9 5/10. Or you can write 5 7/10 minus 9 5/10. I like to write mine like this, just out of habit, because I get to add whether it's positive or add whether it's negative. But if I always write it like this, I already know that plus signs are going to go in the middle. I either do plus a positive or plus a negative, depending on whether a number is a positive or a negative. Now go back up here real quick. I did a plus in the middle, but I know this, if you descend 200 feet, it's not positive 200, it's negative. So I don't get confused about what sign goes in the middle if I keep writing them like this. Okay? All right, so this goes to the right, and this goes to the left. Let me say one thing before I go on. Don't ever, ever, ever put a plus sign if it asks you for the difference, guys, or distance. Don't do that. Difference and distance indicates a subtraction sign or a minus sign goes in the middle. All right, so let's go ahead and subtract. Put the higher number on top. Going to have to regroup here. So now it's more to the left. So the temperature is negative 3.8 degrees Fahrenheit by the time Daria goes to bed. Okay, let's take a look at 17. It is 95 degrees Fahrenheit in Honolulu, and it is negative 5 degrees Fahrenheit in Alaska. So we want to write a numerical expression that represents the temperature difference between the two cities. Okay, now, but look, guys. There is, and I should say two places. All right, sorry about that. All right, now, there's the word difference sitting right there, okay? Difference means you're going to subtract, guys. All right, if you're going to subtract, and this doesn't involve order, I don't know if we went from Honolulu to Alaska or Alaska to Honolulu. Don't know, okay? That's because order is not involved. So you subtract elementary style. When I say elementary style, put the higher number first. So the higher number is 95, so it's going to be 95. Subtract the other number. The other number is negative, so let's put it inside of parentheses, okay? This goes to the right, and this also goes to the right, so it gives us a 100-degree difference between those two places, if that makes sense. Okay, let's look at 18. Pam made a 93 on her math test. She made an 87 on her science test. So what's the difference in her two tests? Okay, this is another elementary difference problem because it doesn't involve order at all, okay? All you need to do is subtract. So it's elementary difference. You just subtract high number minus low number. It has nothing to do with order. So 93 minus 87, or you could have done 93. No, there's no or. Difference, you have to have subtraction sign, guys. I was about to mess that one up for you. All right, 93 minus 87 is 6. There is a 6-point difference between those two test scores. Okay, let's look at 19. The temperature in the morning was negative 7 degrees Celsius. It dropped 10 degrees by lunchtime. So what was the temperature at lunchtime? Okay, so where did it start? It started at negative 7. To drop 10 mean I can add negative 10. Or I can write negative 7 minus 10. It also represents a drop. This is where it started, and this represents a drop. This is where it started, and this also represents a drop. Okay? Again, I tend to write mine with the plus sign in the middle all the time unless it says difference or distance. And then if it says it has a word that indicates that it's negative, I'll put it as a negative. If it doesn't, I put it as a positive. All right, both of these go to the left. So I'm going to add. So at lunchtime, it was negative 17 degrees Celsius. And of course, we know it can't really be that low. Okay, let's take a look at 20. How about you pause the video and you try 20, okay? All right, this is what you should have on 20. A helicopter is 19 and 2,500 meters above the top of a canyon wall. So we know this is positive. It goes down 27 and 6/10 meters. I can either subtract that or put plus negative. Okay, keyword down. And then it goes up 5 and 2,500 meters. So what's the new position of the helicopter relative to the top of the canyon wall? So this is where it started, guys. And then it went down 27.6 meters. So I'm going to put plus negative because down indicates that it's negative. I'm going to show you what else you could have done real quick. Instead of plus negative, you just could have put minus 27.6. But do not, and I repeat, do not do this. Because this is the same as a plus, and it does not indicate that it goes down. A plus indicates that it goes up, so never do that, okay? Make sure your expression matches your scenario that was given in the word problem. All right, let's go ahead. So it went down 27 and 6 meters, and then it went up 5 and 25 hundredths meters. So I'm going to put plus 5 and 25 hundredths, and I can put that on either one. So you can go with either or expression. So now all I have to do now is just establish the direction. That's to the right, that's to the left, and that's to the right. So let's see how far up it was in total and all. You could also go from left to right, adding and subtracting. That's on you. I prefer to put my two together that are positive. So to the right, a total of 24.5 meters, up a total of 24.5 meters. Okay, so I have 24.5 meters plus that negative 27.6 meters. Well, that's to the right, or how far up, and this is how far down or to the left, guys, if you're looking at it on terms of a number line. All right, so these will go, and that's what they gave me, guys. So these two go in different directions. So I'm going to subtract, but put your larger group on top. 27 and 6/10 minus 24 and 5/10, and keep your decimals lined up. And it's more to the left, or it went down more so than it went up. So it's going to be negative 3 and 1/10 meters in relation to the top of the canyon wall, okay? All right, pause the video and try 21. All right, the top of a molehill is 4 inches above the ground. I already know that's a positive 4. The bottom of a mole's burrow is at 9 inches relative to the ground. So it's 9 inches below the ground, okay? What is the distance between the top of the molehill and the burrow, guys? So you have your ground here, and then the top of the molehill is somewhere up here. It's 4 inches above the ground. But then there's a burrow that's 9 inches below the ground. So they've dug somewhere down in here, and that's going to end up being at -9. But it's asking me for the distance between the top and then where they burrowed. And everybody can clearly see that 4 and 9 make a total of 13 inches. But I want you to write the expression. So I'm going to start off with 4 because it's distance. I'm going to make sure I subtract and use absolute value. 4 minus -9. Or you could have written -9 minus 4. Here, this goes to the right, and minus negative is the same as a plus, so it also goes to the right. That gives me the absolute value of 13, which is still just 13. They're actually 13 inches apart. On this side, I would end up with the absolute value of -13 because they both go to the left. I add, but they're negative. But absolute value can't be negative because absolute value represents distance, and distance is never negative, guys. All right, let's take a look at 22. It says the temperature outside was -3 degrees Fahrenheit in the morning. By noon, the temperature was 32 degrees Fahrenheit, still freezing, but much better than -3. What was the temperature change? And it says from morning to noon. So it told me where it started, and it also told me where it ended, okay? It's asking for change. Change is the same as difference, so I'm going to subtract because change is the same as difference, guys. And this difference is not elementary difference where you just put the higher number first. It has order to it. It tells me where I started and where I ended. Okay? So what was the temperature at noon? Because we're going to subtract the final temp that it's talking about minus the start temp. So what was the temperature at noon? Well, the temperature at noon was 32 degrees Fahrenheit minus the start temp, which was -3. That's the expression you want to write. All right, so we actually end up with 32, and this represents a plus, which ends up being the change is a 35-degree change. Basically, the temperature went up 35 degrees, okay? All right, 23. An otter is swimming at -4 2/10 yards relative to the surface of the water. It dives 8 yards deeper. After the dive, what's the otter's elevation relative to the surface of the water? Well, it started here at -4 2/10 yards, and then it dove 8 yards deeper, so plus -8. Or you can say -4 2/10 minus 8. Either way, this represents what that it's underwater, okay? That was a dive and that was an extra dive, indicating that they both go down. So I'm going to add, but remember, if you don't see a decimal and a whole number, the decimal is definitely at the end. So line your decimals up, fill in your empty spaces with zeros, and we're going to add because they both go to the left. Same direction, add. So now the otter is 12 2/10 feet, excuse me, not feet, but yards below the surface of the water, or in terms of a number, it's -12 2/10 yards, guys. Okay, let's take a look at the last one. All right, an AUV, which is an underwater vehicle, guys, is at an elevation of -8 and 2,500 feet. Then it dives down 6 2/3 feet to collect the specimen. Then the AUV dives another 15 3/4 feet. So what's the final elevation of the AUV? So my problem with this one is that two of these are fractions and one of these is a decimal. So in order to add or subtract these things, I need to get them in the same format. So since two are fractions and one is a decimal, I'm just going to go ahead and change that decimal to a fraction. So let's talk about how to do that. So I have -8.25. Well, that 5 ends in the hundreds place, guys. Okay? So I'm going to, when you say and, when you get to the decimal, you say the word and. So that's -8 and 2,500 hundredths. This represents the whole number part, so that's your whole number. And then you have 25 hundredths, or 25 over 100. You write it the way you say it. So if you say -8 and 2,500 hundredths, you write -8 and 2,500 hundredths. Okay, now I'm going to simplify this because both of these are divisible by 25. 25 divided by 25 is 1, and 100 divided by 25 is 4. So instead of -8 and 2,500 hundredths as a decimal, let's write -8 and 1/4 feet. How about we do that? Now everything is in terms of a fraction. That looks much better. All right, so I want to know the final elevation or position of the AUV. So where did it start? It started at -8 and 1/4 feet. I fixed that decimal. Then it dives down 6 2/3 feet. So that's going to be plus -6 and 2/3. And then it dives another 15 3/4 feet. So that's going to be plus negative because it's going down 15 3/4. Okay. Now some of you are saying, well, couldn't I have just done this? And the answer would have been yes. Okay. All right. So all I'm going to do is find a common denominator between 4 and 3. between, excuse me, between 4 and 3, the common denominator is 12. So I'm going to multiply 4 by 3 to get 12, so 1 by 3. So that's going to be negative 8 and 3/12 plus, multiply both of these by 4, negative 6 and 8/12. And again, the reason I'm multiplying by 4 is because 3 times 4 is what gives me my common denominator of 12. So you multiply the whole fraction numerator and denominator by 4. Here I'm going to multiply these by 3. 4 times 3 is 12, so I'm going to say 3 times 3. So it's going to be plus negative 15 and 9/12, guys. Okay, I'm going to erase this so I have more room. And then I can go from left to right, or I can just add up mine that go in the same direction. That's left, left, left. Let's just go from left to right. So if I add these two, that's going to be negative 14 and 11/12 plus that negative 15 and 9/12. Okay. All of them are going left, so I just keep adding. So that's going to give me negative 29 and 20/12. But do you all notice something about the 20/12? Someone should notice something about 20/12. 20/12 is an improper fraction. So I'm going to, what I call T-bow, top in and bottom out. I'm going to do long division. I'm going to put the top number in the house and the bottom number out. Now, how many groups of 12 can you get out of 20? Well, that would only be 1. And how many will be left over? Well, that'd be 8. So this, if the fraction is negative, every part of the fraction is negative. So basically, I have negative 29 plus this part ends up being negative 1. And it goes like the hands of a clock, ticking clockwise, and 8/12. Okay? So because this whole thing was negative, then this piece that I broke up is also negative, okay? So now I add that's negative 30 and 8/12 because I want you to remember this is negative 29 and 0/12 plus negative 1 and 8/12, okay? There are actually 0/12 there. And so we end up with negative 30 and 8/12, and it's in terms of feet, guys. That's the new position of the AUV. And that is all you do. All right, so after this, you're going to make sure that you do that second iReady teacher assigned lesson that I give you on iReady, okay? All right, thank you.